Hi, and welcome back again. It's Mr. Ritzart, and in the last video that I did on potential and kinetic energy, I looked at the relationship between gravitational potential energy and kinetic energy. Now what I'd like to do is solve a problem for you using the information that we had and that we covered in the last video. So the question that we have here is a 5.5 kilogram ball is dropped from a height of 32 meters above the ground. Calculate the velocity of the ball as it reaches the ground. So what we need to do is let's draw a picture of the situation and then fill in any given information that we have. So I know that I have a ball that's up above the ground. I know that it is 32 meters above the ground, and I know that the ball is 5.5 kilograms. Other than that, I don't know anything else. Now it's asking me to solve for velocity. So let's write down all the variables that we know and the ones that we don't know. So it's asking me to solve for velocity, so that I don't know. I do know that the ball has a mass of 5.5 kilograms, 5.50 kilograms, and I do know that it has a height of 32.0 meters above the ground. Now, other than that, let's see, I do know gravity, and gravity is always, it might not be given in the question, but I do know that it's a constant value, 9.81 meters per second squared. So it's asking me to solve for velocity. Now, when I look in the formulas that I'm given in this section, I have potential energy, mass I know, gravity I know, and I know the height. Over here with my formula of kinetic energy, I do know mass, but I don't know velocity, and I do not know kinetic energy. So now we have to go back to our theory and what we understand about the relationship between gravitational potential energy and kinetic energy. So again, if I draw that picture that we did in the last video, I know that when that ball is at a height before it's dropped, its potential energy is going to be 100%, and its kinetic energy is going to be 0. And then when it reaches the ground, it's going to have kinetic energy of 100%. So I can have this relationship that potential energy at the top should be equal to then, because potential energy loss is going to be equal to kinetic energy gained, should be equal to the kinetic energy at the bottom, okay, as it falls. So if I can calculate the potential energy at the top, then I can use that value for kinetic energy in this equation and hopefully solve for velocity. So let's give that a try. Okay, I'm going to just clear my screen. So again, let's solve for, so the first thing I'm going to do is I'm going to solve for potential energy at the top. Okay, so we have that relationship, the ball at the top. I want to solve for potential energy, and I'm going to use that information to give me the value for kinetic energy at the bottom. So potential energy is equal to mass times gravity times height. I know the mass is 5.50 kilograms times 9.81 meters per second squared, and I'm going to multiply that by my height, 32.0 meters, and that is going to give me a potential energy of 1,726.56 joules. So that is the potential energy at the top. Now I know that the potential energy at the top is going to be equal to the kinetic energy at the bottom, because the energy is going to just be transferred into kinetic. So therefore, my kinetic energy at the bottom is equal to 1/2 mass times velocity squared. Now I need to solve for velocity. Now what I want you to do is manipulate this equation and solve for the variable v before we do any of the math. So in order to do that, I'm going to multiply both sides by 2. I'm going to do this in a number of stages. So I'm going to multiply both sides by 2. So what that does is it causes the half to divide out on this side. So now I'm left with 2 KE is equal to mv squared. Now I'm going to divide both sides by m. It cancels out mass on this side. So now I end up with, I'm just going to flip my equation around. I'm going to have v squared is equal to 2 KE over m. Now I have one thing left to do. I'm going to take the square root of both sides. Okay? And that square root, when I take the square root of a squared number, I can eliminate that and eliminate this. So that now gives me, I'll write it up over here, is that v is equal to the square root of 2 KE all over m. Now I just have to put in all my numbers, my information, and solve. So the square root of 2 times, I'm going to use my value for potential energy right here in this equation for kinetic energy. So that is 1726.56 joules. Okay, and I'm going to divide that by my mass, which is 5.50 kilograms. And make sure, sorry I didn't write this properly here, make sure that that square root sign comes down to the bottom. Okay, and then I end up with, when I do all of that work, I end up with 25.1, and that is meters per second. Okay, so now I know that when the ball hits the ground, it's going to be traveling 25.1 meters per second. Okay, so here's again, I'm just going to review what we did. Okay, I solved for the potential energy of the object at the top. Okay, and I know in this relationship that potential energy at the top is going to be equal to kinetic energy at the bottom. Okay, so I use my value to solve for velocity in the kinetic energy formula. Okay, there's going to be a number of different types of problems like this with objects falling. This is the way that you solve them. Again, remember, potential energy lost is equal to kinetic energy gained in this situation. And practice these. Take a look back at this video again, play it back if you need to, and we will see you in class. Science.